So always keep in mind for 2D figure, area vector is perpendicular to the plane, either out, in, out, upward or downward, or right, left, any direction is okay.
Done, sir.
This is X, Y, and Z. I have taken this way X, Y, Z. This is here a circular loop. So its radius is R. Now what will be area vector for this one? If radius is R, so area will be pi R square. It can be either plus or minus k cap, which is along z axis. So can I say area vector for 2D is always normal to the plane, either upward or downward. Both are correct. Okay. For 2D figure, or open surface, always area vector is perpendicular. Always area vector is perpendicular. Shall I rub this now?
Yes, sir.
Now we'll see 3D figure. For 3D, surface or closed surface, area vector is only outwards. Be careful. Huh? So if this is a cube, for this space, if I call this as 1, this as 2, area vector will be perpendicular and outward like this. एक bar. For this side it will be upward, downward. Followed meaning? Always outward, perpendicular to that plane. Hello?
Yes, sir.
Yes, sir.
In this case, you tell me, if this is cylinder, closed surface, what will be direction of area vector to this and this? Only outward, okay? For this also it will be only outward. This is direction of area vector. Now I think you follow. Draw diagram of both A and B. 2D figure. So if it is 2D figure, then outward, inward both is correct. But if it is 3D or closed figure, then only outward and perpendicular to that plane. Can I clear the diagram?
Yes, sir.
Yes, sir.
Electric flux. It is number of electric field lines passing perpendicular to a plane surface. Number of electric field lines passing perpendicular to the plane surface. Like if this is plane surface and we are having one line, two line, three line, four line. So can I say flux due to electric is only two because rest two are not passing through this field. Okay. If we increase flux density, that means more lines comes. Now what is flux due to electric here? 1,
5.
2, 3, 4, 5. That means it is directly proportional to intensity. More intensity, more lines. So flux is directly proportional to electric field intensity. Suppose I increase this area, what will happen?
Flux will increase.
So can I say flux depends upon two things? One is area, other is E. Flux is scalar quantity, A is vector, E is vector. So this becomes dot product of A and E. So the flux due to electric is E A cos theta. Write this definition and copy the diagram. So electric flux is E A cos theta.
Done, sir.
So based on this concept, flux is E A cos theta. Just see 2-3 example. This is plane of the surface. Area vector is perpendicular to this plane. E is making angle theta. That means its one component is E sine theta, other component is E cos theta. So we know flux is all field which is perpendicular. So it is E cos theta into area. So from this also you can say it is E bar dot A bar. Now tell me what will be flux. Those lines which are perpendicular is flux. So this is a surface A bar, E is making angle theta. What will be flux? E A cos theta. Hello?
Yes, sir.
So flux is E bar dot A bar. What is SI unit of electric flux then? E is Newton upon Coulomb, area is meter square. So Newton upon Coulomb, meter square. This is SI. Is completed?
Yes, sir.
So you got idea that flux is A and E in the direction of A, or A bar dot E bar. This is plane of coil. Where is area vector?
K cap.
This way it is outward. And this is electric. What is angle between area vector and E?
90 degrees.
90.
So that means here E bar dot A bar will be E. Area is A square into cos 90.
0.
Cos 90 is 0. So flux will be 0. And we also know when two vectors are perpendicular, dot product is 0. Tell me in this case. This is electric field. Now what will be flux? It will be E A into cos of 0, because area vector will be also in the same direction. That is, can I say E into A square if side is A, cos 0 is 1, E A square. Okay.
Yes.
Can you tell me what will be direction of this flux? No direction, it is a scalar quantity. Okay. Right. Completed this two?
Yes.
This is plane of the conductor. So area vector will be either upward or downward. This is direction of E, making angle 30 degree with plane. Now what will be flux here? E A cos of radius is R. Hello?
Yes, sir.
This angle is given 30. What will be cos theta?
Cos 60.
60 degree. So E area pi R square cos 60 half. So flux is E into pi R square upon 2. Okay. Draw this diagram, write the answer.
Done, sir.
One note writer. For 2D surface. Positive area vector is always along ER. Positive area vector is always along ER. Now we are showing 3D figures. X-axis, Y-axis, Z-axis. This is one cube. E is E naught I cap. E naught I cap means E is acting along x-axis. E naught is constant and direction is along x-axis. Find flux through each phase. So this is one phase, two phase, 3, 4, front to back is 5 and 6. What will be direction of area vector from the first phase? Right or left?
Left.
This will be its area. And for second it will be outward. No?
Yes.
So can I say flux through first phase is E, A, cos of angle between E and A is
180.
180 degree. So E is E naught in magnitude. Area is A square, cos 180 is minus 1. So minus E naught A square is the value of flux phi 1. What will be phi 2?
E naught A square.
E naught A square
A square.
and cos 0, correct? So this is nothing but E naught A square only. What will be phi 3?
0.
0, correct? Because an area vector is upward, angle is 90. What about phi 4?
0.
0. Even 5 flux from 5th and 6th is also 0, correct? Hello?
Yes.
From 5th and 6th phase is also 0. Now can you tell me what, okay, just copy till this, then net flux we are finding.
Done.
What will be flux through entire tube?
0.
Correct. Clearly it is phi 1, phi 2, phi 1 plus phi 2 plus phi 3 plus phi 4 plus phi 5 plus 6 and you are getting answer. That means whenever you see closed cube and charge is not inside, then always you will get flux as 0. Okay, just copy to this and one note write on.
Sir, if charge is inside, then
If charge is inside, then it will be q upon epsilon naught. We are going to prove further. That is called Gauss's law.
okay.
Right now. Thus, for closed surface, Thus, for closed surface, if this is also important, if field is uniform and field uniform is also very important. Field is uniform and charge is not enclosed, then always total flux is zero. This is cylinder. Now E bar is E naught I cap. So E is uniform or non-uniform?
Uniform.
Uniform, because E naught is constant and directed along x-axis.
X-axis.
Orally, can you tell me what will be the net flux?
0.
0. Let us check. So if this is first phase, this is second, this is third, this is fourth. So this is area vector A bar, area vector A bar, area vector A bar, area vector. So phi 1 is E naught in magnitude. Area vector is this area which is pi r square, and angle between E, which is on x-axis, right side, area vector on left, cos 180. So I can say minus E naught pi r square. Flux on second phase will be E naught pi
Pi
r
r
square cos 0, which is 1. That means it will be minus E naught pi r square. So flux through third and fourth will be 0 because area vector is
Sir, why
perpendicular.
minus?
Which
In
one?
second one.
No, it
In
is plus.
second.
Plus. Then flux through third and fourth phase, can I write directly 0?
Yes.
Because area vector is perpendicular. Now total flux will be also. Next question, copy.
लाइन का मैडम देखना पड़ेगा चेक करो अपना दुकान पर सारे गया ही है और ये तो कुछ महंगा ही आता ना
तो फिर अपने को नया लाइट है
ये
चेक करा लोग नहीं करा कहाँ लगाना है तो मेरा अभी आपको कितना देना है
320 का सामान था टोटल लाइन को मैं अभी बताता हूँ आज
उसका भी लेना पड़ेगा, फिर बाद में सकता। वो शायद लाइट आएगा 200 रुपए में आएगा।
जो भी है
अगर कोई साइज का दूसरा भी स्टाइल मिले तो चलेगा, ऐसे भी फिट होना चाहिए खाली जगह।
ये जो समूह है वो बराबर है
हाँ बस उतना ही, बाकी फिर कोई भी स्टाइल चलेगा।
नहीं टिंकी लाइट है ना इसको टिंकी लाइट होगी आड़ा टेढ़ा कर सकते
नहीं, अपने को ऐसे जरूरत नहीं, सीधा वाला मिला तो भी चलेगा, कोई जरूरत नहीं कि वो टिल्ट करे।
इसमें कभी याद रहेगा
नहीं याद रहेगा
तो एक वो भी ले और
फिर जब नेक्स्ट टाइम आएंगे तब हिसाब
भी
करेंगे।
लगाना है, उसके लिए एक बल्ब लगेगा। तो तब्दील देखो आप एक साल लगाए थे तो ये अभी आप ही जान तो आज दिखाइए थोड़ा बात नहीं करना है क्योंकि उसका कनेक्शन करना पड़ेगा, थोड़ा उसका वायर का ना कनेक्शन इससे करना।
इसी प्लग में डाल देंगे एक ही वाला दोनों ऑन रहेगा।
हां देखते हैं उसी
is completed this diagram?
तो उसमें भी वो लोग लग रहे हैं।
Yes, sir.
Yes, sir.
Now see, be careful. If field is uniform, then only you are getting flux as zero. Now, if I say E is E naught on xi,
हाँ होल्डर है ना।
is the field uniform or non-uniform? Is this field uniform or non-uniform? Yes, because at different value of x, E will be different. So suppose this is a cube. Very nice. This is at distance of A, and this side is also A. So one face, second face, third face, fourth face, front and back, 5 and 6. Flux through first one will be E into A into cos of 180, because clear cut direction is along positive I cap. So E is E naught, but what is distance of x from here, from this origin? The formula is E naught x, area is A square, this is minus 1. So E naught, what is x at this phase, first phase? How much is x? Is it A?
A.
A, correct. Into A square minus 1. So it will become minus E naught A cap. Flux on the second phase is EA cos 0. So it is E naught x A square into 1. This is E naught. Now what is x?
2A.
2A, correct. Because at this phase, distance is not A. A plus side A 2A into A square. So I will get 2 times E naught A cube, correct?
Yes.
And what is fourth one? Third will be this way, area vector 0, correct? So flux on fourth and third, both are 0. Flux on 5 and 6, also 0.
0.
What will be net flux this time? Minus E plus 2 times E. Minus E naught A cube plus 2 times E naught A cube. That means E naught A cube, correct?
Yes.
Now concept followed. Now here we are not getting 0, even though field is no charge is inside, because field is continuous. So when no charge inside, field is uniform, then we get flux as 0. Otherwise it will not be. Copy full.
Done, sir.
A few numericals I'm doing so that theory you can revise, you will get time. Next class we'll do electric flux through disk, electric flux through sphere, Gauss's theorem, and based on Gauss's theorem, 4 intensity. That will complete electric field and force wala part. That will take 2 lectures. And next lecture then we'll start with potential, potential energy, kinetic energy, and then capacitance. Just open the PDF if you are having electrostatic one. Page number 20.
39th page.
Number 39. And how many we have done? 19th we did, I think.
19.
20 we have to do. 20. See, एक आध theory नहीं हुआ रहेगा, but still I am explaining it so that we are not missing any sum in sequence. Electric potential inside charged spherical ball is given by phi equals AR square plus B. So don't get confused. This is not flux. That potential is given by AR square plus B, where R is the distance from the center. So if this is spherical ball, potential V at distance R is given by this formula AR square plus B. Then what will be charge density inside the ball? What is meaning of charge density? Meaning of charge density? Charge density inside the ball. Hello? Charge density inside the ball means denoted by rho, which is charge per unit volume. Okay. So it is charge upon 4 by 3 pi r cube. Have you followed this concept?
Yes, sir.
So they want what is charge density inside. So if I get Q and this is volume 4 by 3, then I will get charge density. But now my problem is to get Q first. This is V. Potential means V is AR square plus B. To get charge, we can find flux because by Gauss's theorem, flux upon epsilon naught is equals to electric field intensity. Hello?
Yes.
Yes.
We are going to study further in Gauss's theorem. Q inside upon epsilon naught is nothing but flux. Q upon epsilon naught is nothing but flux. Okay. Any relation? Can you recollect between V and electric field intensity E?
Sir, V is equal to E into R.
Okay. बट एकदम अगर कॉन्सेप्ट वाइज जाएंगे तो E is minus dB by dr होता है ना.
Yes, sir.
ये रिलेशन अभी तक मैंने किया नहीं क्योंकि पोटेंशियल वाला पार्ट हुआ नहीं. So E is minus dB by dr. This you have to remember every time. Because if I get E into area will give me flux, and by Gauss's theorem Q upon epsilon naught will give me flux. So from B, any musical sound you are hearing in between? Hello?
No, sir.
No, sir.
No, no, so लगता है मुझे खाली सिस्टम था ठीक है. E is minus dB by minus. What is AR square का derivative?
2A.
Very good. 2AR. B is constant. 0. So can I say E is minus of 2AR. Is minus 2AR. Okay. Now flux phi is EA cos theta. Charge is inside. तो ये सब इंटेंसिटी स्फीयर से रेडियली आउटवर्ड होगा ना? हेलो?
Yes, sir.
If charge is inside, then this will be radially outward. So can I say flux will be Q upon epsilon naught equals to E, which is minus 2AR into area. How much is area? 4 pi R square. इतना कर लो कॉपी. Important sum है ये JEE में आया है. So flux is, this is not flux, don't get confused, it is voltage. We want charge upon volume. So I am interested in getting charge first.
Done, sir.
So you got Q upon epsilon naught. Therefore Q equals to minus 8 pi भी है, 8 pi epsilon naught. What else is there? R square is there? Hello?
R cube ना सर.
नहीं, उधर क्या था? 2AR into 4 pi R square R. Now charge density is charge upon volume minus 8 pi epsilon naught R cube. Volume is 4 by 3 pi R cube. So pi R cube cancel 4 into 2. So it is minus A भी है ना शायद बीच में?
Yes sir.
So this is nothing but minus of 8 to 2 6.
Minus 6.
6 epsilon naught A. है क्या ऑप्शन देखो ऐसा?
Yes sir.
It's our required answer. Slightly difficult sum because three concepts are there here. Gauss's law, relation between electric field intensity and epsilon naught, and also charge density mean.
सर ऐसा नीट में भी आएगा?
हाँ क्यों नहीं आ सकता है? ये सब चैप्टर तो है ना. इधर 6 pi मतलब D वाला आंसर है because in magnitude they have given 6A epsilon naught. Pi is not. देखो नीट को हमेशा आप एकदम सिंपल मत समझो. ये लास्ट 2 साल से इजी आया है, लेकिन नीट में भी डिफिकल्ट मतलब रिलेटेड टू टॉपिक होगा. wherever it is maximum maths part, that will or may not come.
Okay sir.
Can we go to next one now?
Yes.
A and B are equipotential lines. What is meaning of equipotential lines?
Having same potential.
Correct, having same potential. So it is A and B are two equipotential. दोनों का वोल्टेज सेम नहीं है, मतलब ये अगर 10 होगा तो ये 12 होगा थ्रू आउट. ये भी नहीं, थ्रू आउट इधर 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 हर जगह पे सेम पोटेंशियल. A and B are two equipotential lines in an electric field. 4 charges OC, OD, OE, OF. 4 paths OC, OD, OE, OF are as shown from point O. Work done in displacing charge Q along this path is equal, maximum, minimum, or maximum along OC. See, to move a charge from A to B, work will be done. So potential difference between B and A is work done to move the charge from A to B. This you know. Potential difference from B to A is work done to move the charge Q from A to B. Is that clear?
Yes, sir.
देखो उल्टा लिखा है मैंने, समझा ना आपको क्यों? Because at infinity there is no potential. So suppose you are coming at point A. Here potential or work done is 10 joule for moving that charge. Here it is 12. So when you are moving the charge from A to B, work done from A to B will be potential difference between B and A ना? Because ये higher है. तो ये हमेशा उल्टा होता है. VB minus VA is work done A to B. So these are equipotential, मतलब ये B तो A भी V ना? Equipotential है ना ये? मतलब ये
Yes,
एग्जांपल
sir.
दे दो, ये 10 है, अलग-अलग वोल्टेज, 8 है सपोज. So
तो फिर
O,
वर्क डन सेम होगा ना?
so ये O to C, O to D, O to E, O to F, हर एक का पोटेंशियल डिफरेंस सेम है क्या अलग है?
सेम है.
So from for OC or OD or OE or OF, potential difference is same. So can I say therefore work done is same?
Yes.
Answer will
Yes,
be
sir.
work done is same. ये नीट का फेवरेट है. Work done is same because potential difference is same. If potentials are same, then work done will be zero. Done.
Yes, sir.
Next numerical problem. A closed surface is shown in adjacent figure. This is for closed surface. Here we have charge minus 3 coulomb, 6 coulomb, and 4 coulomb plus. The outside direction of the closed surface is shown in the adjacent figure. Total normal electric induction over closed surface is equal. So just remember this is equals to charge enclosed. Total normal electric induction is charge enclosed. What is charge enclosed? Minus 3 plus 4 plus 6.
7.
Minus 3, yes, 7. So answer is 7. Positive इसलिए outward होता है. So 7 coulomb.
Done, sir.
Electric field due to infinite plane of charge having surface charge equal to sigma is E at a point near the plane. Electric field due to infinite plane having charge density sigma is E at a point near to this. Electric field due to infinite conducting plane. Infinite conducting plane having the same amount of charge as before at the same point between. See, if it is infinite conducting plane That means it is slightly thin conducting plane having charge on both sides. So at this point, intensity is sigma upon epsilon, and for this conducting sheet, E dash is given by sigma upon 2 epsilon, because both side charge gets distributed. So I can say E dash upon E is sigma upon 2 epsilon into this. So I can cancel. Therefore, E dash will be E upon 2. This is the derivation I will explain in the next lecture by using Gauss's.
सर ये एक बार और एक्सप्लेन कर दो ना, सिग्मा अपॉन 2e।
देखो अभी इसमें कुछ एक्सप्लेनेशन जैसा नहीं है, क्योंकि फॉर्मूला डेरिवेशन एक्सप्लेनेशन होगा। तो इलेक्ट्रिक फील्ड ड्यू टू इनफाइनाइट प्लेन ऑफ चार्ज, ये प्लेन ऑफ चार्ज है, चार्ज का प्लेन है, तो चार्ज एक ही साइड होगा ना। लेकिन अगर मैं कंडक्टिंग के ऊपर चार्ज रखूं, दोनों साइड हो जाएगा ना चार्ज। जैसे इंटेंसिटी एक ही तरफ रहेगा, यहाँ पे दोनों तरफ रहेगा, इसलिए ऐसा। हेलो,
ओके सर।
Yes, sir.
फिर डेरिवेशन में मैं आपको समझाऊंगा कैसा है।
Done, sir.
Actually, this year polarization effect is removed from the syllabus. थोड़ा explain कर देगा। Polarization of non-conducting medium, that is insulator. The internal field is EI produced. That means these are two plates of conductor. Here I place insulator. Then this insulator charge will get slightly displaced by the pulling force. So due to induction, positive side will get negative wala charge, and this negative will get positive wala charge. So there will be electric field outside or external from positive to negative, and internal it will be from negative, this positive to negative. So that telling direction of field EI with respect to external will be where? It will be always
Parallel and opposite.
Parallel and opposite. So C option.
मेरे को लगा कि थोड़ा लाइन से रहता। मैं यहाँ से स्टार्ट करती हूँ, वहाँ से स्टार्ट। थोड़ा सा कर दीजिए।
Done, sir.
Next one, if C is capacity of parallel plate condenser whose two plates are separated by distance d, each plate has area A and medium between two plates is of dielectric constant K, then which relation is correct? We know capacity of parallel plate condenser is AK epsilon 0 by D. That means C is directly proportional to area. C is directly proportional to K. C is inversely proportional to distance. Check where it is given. Option D. Hello, is it option
Yes.
D? Easiest part is actually capacity, and toughest part is electric field because of direction. A capacitor has capacity of 55 microfarad in air. So when dielectric medium is air, capacity is 55. And 110 microfarad when immersed in oil, then what is dielectric constant of time? C is A K epsilon 0 by D. So I can say C1 upon C2 is K1 upon K2. C1 55, C2 110, K1 is 1 upon K2, 55 upon 2. Therefore, K2 equals to dielectric constant is 2. Done?
Yes, sir.
Yes, sir.
A 4 microfarad condenser, 4 microfarad condenser is charged to potential of 1000 volt. A resistance of 1000 ohm is connected across the condenser, then heat dissipated in the resistor. What is heat? Is it energy?
Yes.
So can I say heat dissipated is same as energy stored between the plates of condenser? See, to confuse, they have given resistance value. Now, so far I have not explained theory of energy stored in the condenser, but you all know it is half CV square. Correct? Huh? Energy stored is half CV square.
Yes, sir.
Now C is 4 microfarad multiply with 10 raised to minus 6, and B is 1000 10 raised to 3 square, 2 into 2 square. So this is 2 into 10 raised to minus 6 into 10 raised to plus 6. So it is equals to 2 joule of energy is dissipated across the resistor. 2 joule. Option A.
Done, sir.
Equal condensers connected in parallel. One condenser, two condensers, three condensers are connected in parallel to a cell of EMF 2 volt produces a throw. Throw means deflection of 18 centimeter when combination discharges through ballistic galvanometer. So when it sends the charge through ballistic galvanometer, it gives deflection of 18 centimeter. If this condensers are in series across same battery of 2 volt, the throw produced will be how much? What is same in both?
Voltage.
Correct. Voltage is same. Throw is given in 18 centimeter means deflection is 18 centimeter here on the arc. And we know length of arc is r theta. तो दोनों needle का r same होगा बराबर. So when you take r1 upon r2, s1 upon s2, it is same as theta upon theta 2. So deflection का ratio can be written in arc ratio. What is ballistic galvanometer? Ballistic galvanometer is a galvanometer which produces large deflection when charge flows through them. Charge flows through them. So ballistic galvanometer is galvanometer which will show deflection when charge is flowing through them. So this is C, this is C, this is C. I can find what is charge flowing through this because here theta is directly proportional to the charge. This is ballistic galvanometer where deflection is directly proportional to charge flow. Just draw this two diagram, write this much, then I'm explaining. थोड़ा अलग टाइप का सा. First diagram can I run? First one?
Yes.
Yes, sir.
I'm just finding what is total charge in first case, total charge in second case, then I'm taking ratio, you will get the required answer. Yes, what is equivalent capacity of 3 condensers in parallel?
3C.
C1 plus C2 plus C3.
3C. So in case 1, total capacity is 3C and total voltage is 2. So Q total is C total into V total, correct?
Yes, sir.
Because Q is nothing but C into V. So it is 3 C into 2V. So first charge is 6 times C. Have you followed this much?
Yes, sir.
Yes, sir.
Now in second case, okay, first you draw the diagram of second one. In case 2, total capacity will become C by 3. Voltage is same, that is 2V. And charge in the second case is total capacity C by 3 into total voltage. Then since Q is proportional to deflection, therefore 6 times CV upon 2 CV by 3 equals to first 18 centimeter, second wala you have to find. CV cancel, 3 goes up, 18 upon 2 is 18 upon theta 2. Therefore, theta 2 equals to. That means the deflection will be equal to 2 centimeters. Yes, you followed first, meaning in ballistic galvanometer,
Yes, sir.
charge is proportional to deflection. So I just found what is charge in first case and second case.
सर Q directly proportional to theta, ये कहाँ से ड्राइव किया?
हाँ, वो प्रॉपर्टी है बैलिस्टिक गैल्वेनोमीटर का. देखो मूविंग कॉइल गैल्वेनोमीटर पता है आपको?
हाँ सर.
उसमें I is proportional to theta है ना?
हाँ हाँ हाँ.
I मतलब चार्ज
हाँ,
होता
Q
है.
is equal to I. हाँ सर.
Because I के जगह Q upon time लिख सकते हैं. So all the sums please
Done, sir.
revise. Or this 29 में there is some error, so I will just cross check and then we'll do. You all try to complete till 40. 50 तक मैंने बोला था शायद. ट्राई करना, अगर खुद भी करते हो तो थोड़ा फास्ट काम होता है. Tomorrow 12:30 time.